Now we are going to solve time period of this so-called oscillating block. Okay. Generally, time period of a oscillating block formula is T is equal to 2 pi square root of m by k effective. Effective mass divided by effective k. Here only one block only is there. Only one block only is there, so that effective mass is m. Here k, so many k's are there, so that we have to find k effective. After finding k effective, that k effective we have to substitute in this formula. Then we can get time period of a oscillating block. So to find k effective, after finding k effective only, we can get a time period of this oscillating block. Now we assume here T is the time period. Okay, here T is the time period. Let us assume tension in the block is M. Let us assume tension in the block is M. Here time period already we taken in symbol T, so that let us take time period symbol is T dash. Time period symbol is T dash. Sorry, time period symbol already we taken T. Now we take tension symbol as T dash. T dash we have to take here. Here T dash we are taking. Here this block M, let us give displacement Y. Y amount displacement we give. If we give Y amount displacement, then here pulleys, two pulleys are there. Let us assume this is the second pulley, this one is a first pulley. Now we assume this first pulley as undergoes displacement of Y1. So that is first pulley displaces Y1 displacement, it undergoes. That means here this 2K spring undergoes extension, Y1 extension. Y1 extension is there. Now let us assume pulley here second pulley is there. This second pulley as undergoes displacement, downward displacement as a 2y2. Second pulley undergoes displacement as 2y2. 2y2 displacement, the second pulley undergoes displacement. We assume second pulley undergoes 2y2 displacement, then first pulley has to move downward y2 distance, y2 displacement. Here second pulley is displacing downward 2y2 displacement, then this first spring has to undergoes displacement, that is stretching, is 4y2. 4y2. Okay, now tension in the 2K spring is T dash, then tension in the strings are there, no? In the string should be T dash by 2, and in this string should be T dash by 2. In this string T dash by 2, then here in this string tension should be T dash by 4. T dash by 4, and in this string to be T dash by 4. Now we write some conditions. We know that tension is equal to strength, tension is equal to force constant into stretching. If we take spring K, for spring K we take tension is T dash by 4. T dash by 4. That is equal to K into 4y2. K into 4y2. From this we can get y2 is equal to T dash by 16K, and spring, let us take 2K. Let us take spring 2K. In that spring 2K, it is undergoes extension is y1, so that T dash is equal to 2K into y1. From this we get y1 is equal to T dash by 2K. T dash by 2K. Then now we see here Here this block undergoes displacement y displacement, so y is equal to y1 plus y2. Now we substitute y and y1 y2. Value of y is equal to y1 plus y2. Y1 is how much if we take t dash by 2k, and y2 is t dash by 16k. y2 is t dash by 16k. y2 is t dash by 16k. Now let us take LCM. y is equal to LCM is 16k. Let us take LCM as 16k. So that how much we are getting means in numerator 8 t dash plus t dash. So that we are getting 9 t dash is equal to 16k into y. 16k into y. Now t dash is equal to 16k by 9 into y. In general formula, in general t dash is equal to k effective into y. Now k effective how much comes means this k effective is known as this value. So k effective we are getting is equal to 16k by 9. Now this k effective we have to substitute in the time period formula. Here time period formula is in first place is there. This is the time period. In this we have to substitute. If we substitute time period, we get time period t is equal to 2 pi square root of m divided by 16k by 9. So 16k by 9 will go to numerator. So this is the time period of the so-called oscillating block. This is the time period of the so-called oscillating block. Okay, once more let me repeat this explanation. Here time period of a oscillating block we have to find. Here pulleys are there. This is the second pulley, this is the first pulley. Here spring is there, here one spring is there. In this spring force constant k is there, here force constant 2k is there. Let us assume block M is given y displacement. Here spring undergoes y1 displacement, and here this pulley undergoes downward displacement 2y2. So that this pulley undergoes downward displacement y2. So this pulley downward displacement and this spring extension all together is equal to y. So that y is equal to y1 plus y2 we have written. And in this spring, here this pulley is undergoes displacement 2y2, then this spring has to undergo 4y2 displacement. That is, next one is in this spring tension t dash is there, so that here t dash by 2, here t dash by 2 tension should be there. And since here t dash by 2 tension is there, so that here t dash by 4 tension is there. Now these springs we are taking under spring k. For spring k tension is t dash by 4 is there. In t dash in spring k extension is 4y2, so that tension is equal to k into 4y2. Next we are taking spring 2k. Spring 2k we are taking. In spring 2k tension is t dash is there. Extension is y1 is there, so that force constant into y1 we have taken. From this y1 is equal to t dash by 2k is there, and y2 is equal to t dash by 16k is there. Actually we need time period. For that 2 pi root of time period formula, 2 pi root of m by k effective is there. So now we are substituting in the place of y1 and y2. Here we found y2 and y1. These values we are substituting. Y2 and y1 we are substituting here. Y2 and y1 we are substituting in the place of y1 and y2. Y1 and y2. Yes, here y1 is there. This y1 we are substituting here, and here y2 is there. This value we are substituting here. So by substituting, we are getting y value. Y value is like this. Y value is there like this. After rearranging tension formula, we are getting T dash equal to 16K by 9 into Y. In general formula, T dash equal to K effective into Y. From this, we are getting K effective equal to 16K by 9. This 16K by 9 is known as effective force constant. This effective force constant we are substituting in this formula. By substituting in this formula, we are getting time period of the so-called oscillating block.